Hey guys, I'm gonna go through this review and get through as much as I can. I'm gonna do this, if I can, in 3 parts. I'll go through all the area problems and then all the revolution problems and then all the cross-section problems. Just what I have time for, because I think this might help you guys prepare a little bit. So don't feel like you need to watch everything. Feel free to skip around, but hopefully this will help you review if you're getting a little stuck. So we're going to start with number 1 and number 2. Both of these are area problems. And remember, the first thing that I should think as soon as I see area, I'm just going to make a little box over here. When I see area is I need to do the integral of top minus bottom. Now this is simplistic because this doesn't tell me if I'm doing dx, dy, or if I'm doing, or like what my intersections are, but this is just a general, like if I'm doing any area problems, this is the formula I should be using. So this is for 1 and 2. So I put the arrows. So number 1 says find the area of the region bounded by the graphs of y plus x squared equals 6. Well, let me quickly rewrite that just to help me as y equals negative x squared plus 6. And I'm going to rewrite this as well. This is going to be y equals negative 2x plus 3. Okay. So remember, step 1 is always to draw a picture. So if I were to draw a picture, I'm going to start with my parabola. I notice I'm going to go up to 1, 2, 3, 4, 5, 6. And a parabola always opens up, like when you go over 1, you're going to go down 1 on either side, because 1 squared is 1. So if I move 2 over, I'm going to go down 4, because 2 squared is 4. So that'll at least get me started. And now I have the line y equals negative 2x plus 3. Well, if it's plus 3, I know it crosses here. And I know my slope is negative 2. So if I were to go over 1, I'd go down 2. Or if I were to go backwards 1, I'd go up 2. So conveniently, I know what one of my points is. This point here is going to be backwards 1, up 5. But we don't know what this one is yet. So remember, my second step after I draw my picture is to find my bounds. And also I should point out, I'm finding the area of the region bounded by these 2 things. So I just want to figure out what the area of this is. So if I want to find my bounds, I need to figure out where I intersect. And that's going to be when a negative x squared plus 6 is equal to negative 2x plus 3. Well, I'm going to get everything on one side. I prefer having a positive leading coefficient, so I'm going to move everything over here. So that's going to give me an x squared minus 2x. I'm going to subtract the 3, so minus 3. Sorry, I should have to think about that for a minute. Okay, now I'm going to factor. That's going to give me an x minus 3x plus 1. So now I know my bounds are going to be at, like we said, negative 1, and they're going to go until x equals 3. So those are my bounds. When I have an area, I don't have to worry about that radius or the length or anything. It's top minus bottom using my intersection points. So now I can say that my area is going to be equal to the integral from negative 1 to 3 of the top curve. Well, the top curve is the parabola. So the top curve is negative x squared plus 6 minus the bottom curve, which is a negative 2x plus 3. And that's all going to squeeze in my dx real fast. That's not the prettiest. Sorry, guys. Now I'm going to just evaluate in my calculator. I'm going from negative 1 until 3. Remember, it's good to practice typing these in. It's easy to make mistakes. I have to be careful with these parentheses here. I want to make sure I'm taking the integral of all of this. Right, so I'm going to do my opening and closing brackets are already here, so I'm going to start here. I'm going to have a negative x squared plus 6 minus negative 2x plus 3 dx. Uh-oh. Let's see what I did. Negative, ooh, that's probably supposed to be a minus sign. There we go, or a negative. Negative x squared plus 6. So when you get errors like that, a couple things to troubleshoot are, like what I just found was I had used a minus sign instead of a negative sign. I know in the past I've forgotten to put an x in the dx. So just, that's a good way to troubleshoot. Okay. Depending on, if this was a free response problem, leave your answers 10.667 or 10.666. We can round or truncate. But if it was multiple choice, there's a good chance it'd be an exact answer. So I'm going to turn that into a math frac, which is 32/3. So let's see if we can do another area problem now. Area of the region bounded by the graphs of y squared equals 4x. If I were to divide by 4, I have 1/4 y squared. So that's just telling me that my sideways parabola is just getting stretched. It's not shifting it. It's still going to go through the origin. So I have this. Actually, I probably would have squeezed this way, but that's fine. And then I have y equals 2x minus 4. Well, that means it's crossing down here. It's got a slope of 2, so I'm just going to kind of guesstimate. And I want to find the area of this region. Well, what I noticed right away is if I did top minus bottom, I'd have trouble because here my top and my bottom is the parabola and the line, but over here it's the parabola and the parabola. So I'm actually going to do this as something with respect to y, and I'm going to make my left-hand turn, because when I make my left-hand turn, hopefully you can see now it's really clear that this line is the top and the parabola is the bottom. So we'll keep that in our mind after we turn it back. The line's the top, the parabola is the bottom. And we do a left-hand term to make the positive x the top and the negative x the bottom. Okay, so we need to find these intersection points. The next thing I'm going to do is I'm going to find my bounds. Because I want to do everything with respect to y, I need the y values. So I'm going to go over here real quickly. Let me look at this real fast. Yeah, and I'm going to solve these both for x. So if I were to do that really quickly, this is going to give me x equals 1/4 y squared. And if I solve this for x, I'm going to get y plus 4 equals 2x. So x would equal 1/2 y plus 2. So if I want to find my bounds, I need to figure out where these things are equal. I'm going to start by getting all of that on one side. And if I'm honest, I don't really want to factor this in the form that it's in. These fractions are kind of gross. So I'm going to multiply everything, both sides by 4 to make this something that's a little bit more easy to, or a little bit easier to factor. So if I multiply both sides by 4, I end up with y squared minus 2y. I feel like, oh, when I moved this 2, I forgot to make it negative. So minus 8 equals 0, and when I factor that, I'm going to get a y minus 4 and a y plus 2. So that means my bounds are going to be from -2 to 4. Okay, so now I can do my integral. So my area is going to equal the integral from -2 to positive 4 of the top curve. Remember we said the top curve, when I do my left-hand turn, is this line. So 1/2 y plus 2 minus the bottom curve, which is the parabola, dy. So now I'm going to type that into my calculator. I'm going to go math 9. I'm going from -2 to 4. I've got 1/2. We can only use x's in here, so 1/2 x plus 2 minus 1/4 y squared, which I'm going to type in as x. And there's my dx. Your calculator doesn't give you the option of typing in the y, so we're just going to use, we'll switch them all to x's and still type it in as x's and dx, but we know that for this graph we're doing it with respect to y. Okay, and that gave me an answer of 9. Nice pretty number. So I'm going to stop this video and you guys can open up another one. I'm going to start one on revolving area of volume by revolution.